we're going to continue on lectures. Okay. Right. So again, the important concepts to know about with Panda and data frames is the three different major data structures: data frame, the series, and indexes. And that with the data frame, we have different kinds of access methods or AP functions off of the actual data frame. So filtering, the lock function, iLock, group by, and pivot. So once we do get, either we've been given the data or we've collected the data, what should we do next? So this is the time that you guys should be thinking about your semester project or thinking about your question. As I was mentioning to one student earlier today, one student wanted to measure certain levels of toxins in the ocean water right off of Torrey Pines, because he was a avid surfer and he'd been surfing around the San Diego area for many years. And so he wanted to know, based on what kind of factors these various toxins would rise up very high. And so he would measure it across the year. Well, he wasn't actually measuring it. He was actually depending on the state governments to do the measurements for him, and he was just picking up on their data. But then he was analyzing it based on certain kinds of conditions, weather conditions in the San Diego area, and then looking at those various factors. And then the output was the toxin levels in the ocean. Okay, so for him, his question was, how safe was it for him to go surfing? Okay, and that was then driven from these various toxin levels in the ocean. And then looking at what then contributed to those various toxin levels off of the coast of San Diego. So after he acquired the data, so he got the data either from this government website or agency website, then he was exploring it to see which ones of the data he wanted to focus in on. And then he eventually did some predictions and inferences from that, okay? And then so he kind of was a little bit more I guess, initially focused on that question of whether it was safe for him to go surfing. But as you look for your question, another topic that came up earlier today was climate change. So climate change can mean many different things. It can be how extreme hot or how extreme cold do our summers and winters are, or it could be the effects of the farming yields, or different kinds of things in the weather, right? So it could be winds, it could be the Santa Ana winds. So different kinds of things that we can measure. So we want to be able to look into how do we do this data acquisition, and then once we do acquire the data, we want to do some exploration of that data and analyze that data. Let's go through this. Okay, so we're going to look at some examples of data that I uploaded to Canvas, and then look at the data, try to understand what kind of data we're looking at, do some data cleaning, and then maybe do some little bit of data manipulation, and then understand some common kinds of problems with the data or common kind of data anomalies, and then how to fix them. So this is the process that you might be doing quite, you're going to be spending a lot of time actually looking at your data, exploring the data, and then cleaning the data, and then going back again, exploring the data again, and then cleaning it again. So it's kind of a little bit of a repetitive cycle, at least in the early part of your data analysis or machine learning process. So we're going to talk about data cleaning, and the first part is the process of transforming our raw data into some kind of subsequent analysis. Okay, so you could think of it this way. We're going to see some examples where we got some raw data and it contains, how you say, unprocessed data, meaning it hasn't been converted into a way that we can easily understand it. So let's say GPS coordinates. If someone just gives you GPS coordinates, for me, I don't recognize GPS coordinates of where I am right now. So if someone gives me my GPS coordinates or shows me a GPS coordinate, I don't exactly know where that is. Maybe I might recognize like maybe just San Diego or like Japan or Korea, but that's probably about it. But any place else in the world, I won't recognize it. But when you go to maybe more specific areas, let's say within the greater SoCal area, all the various GPS coordinates around there, someone just says, well, this is just for SoCal. That's really too broad, right? But if someone tells you, oh, this is like Newport Beach, or this is like Cerritos, there's the kind of neighborhoods or the kind of people and economic or situations and weather and things like that are really different in those two different areas. And then we talk about, how do we take care of some of these data cleaning issues, okay? And then we're going to talk about how we can structure and reformat this data. And then how do we handle missing or corrupted values in our data? And then also take care of unit conversions. And then encoding text as numbers, and then we're going to see the other way, encoding numbers as text. Okay. Okay. So encoding text as numbers, this is a case where we'll see it in the data that we kind of go over today, which is the police reports. And as people are entering their police reports, they call it call for service, okay? So there's a dispatcher or somebody who writes up the report of what happened when a police officer visits a call, and they have to write up why they went out, what did they find, and so forth. Some things are maybe they pick something from a list and they just pick it. But other things, they have to enter something in. And when they enter that thing in, maybe they'll do some kind of consistency with the data, but a lot of times they're not really consistent. And that's when we've got to convert these kind of text that they enter into something that's numeric, and then be able to deal with it numerically. Like if we're talking about disturbance of peace versus domestic violence in the house, or let's say drug use, things like that. Some of those might be just, numerically already entered into the system because it's just like a list drop down. But other things, you're going to have to convert from text into some kind of number. And last thing is that basically data cleaning is going to be a large part of our work. So we're going to try to get to, so the EDA or exploratory data analysis. You're going to probably hear that often. So it's about getting to know your data. All right, so here on EDA, what we're going to do is we're going to be transforming, visualizing our data, and then summarizing our data. So what you have done so far, well, actually what you're going to be doing right now in this current assignment 2, you're going to be doing a lot of that transformation of data. And because you're going to need it to transform it to be able to do some of those measurements that are part of assignment 2. And visualization that you saw when we saw the, for example, you saw the graph of the like Michael being the largest number, and it kind of how it just dovetails down in descending order. So you saw this large spike of numbers. So what you can sort of see there is this. If we were to take out the top 5 names of that most popular names, would that rest of the data have a more, let's say, expected kind of curve? Or would it be just like this kind of like everybody's names seem to have a similar kind of popularity besides the first top 10 or top 5? So besides the most popular names, does everybody else's name have that similar kind of distribution? Okay, so that's the kind of data analysis that we want to think about. Not just look at, okay, you can look at these outliers like Michael, but then if you take out the outliers, how well does the rest of the data perform? And how well do they behave? Okay. Okay, and the next part, which is really important in your report and as your work as a data scientist, is your journaling. So as you are actually transforming the data, you actually have to keep track of what kind of changes you're making to the data. And this is why we actually want to see the Jupyter lab file. Because if you just show me the end result, then I don't really know how you went and transformed your data and how you cleaned up your data. But your lab report, along with the Jupyter file, will hopefully show that work that you did from taking the raw data and then transforming it, cleaning it, moving the data around, grouping it around, and then coming up with your final numbers or final analysis. Okay, so that's the reason why journaling is going to be very important when you write up your Jupyter lab file, because that's going to show what kind of changes you've made to your data. Okay. This fellow here, John Turkey, Princeton mathematician. So he actually coined the term bit, and one of the early pioneers of EDA work. Okay. The next part is about data types and understanding the different kinds of data types that we're dealing with. I'm just going to just show them all. All right, so across all the different kinds of data that we come across in the world, there's basically 2 types, right? One is quantitative and the other is qualitative. So under quantitative, then we have 2 different types: continuous values or discrete values. So when you think about like temperature or prices, it has sort of like a range, and it kind of flow from one end to another. Whereas discrete values, things like number of cylinders in the engine, number of years of education, number of minutes, or number of shots made on the basketball hoop. Those are discrete numbers. The other one is qualitative. So there's two types, nominal and ordinal. I think you know everyone's sort of familiar with these, like on the nominal part, political affiliations. There's no specific ordering, like Democrat or Republican. It's not like one above the other or independent. And then ordinal values, like so preferences, you can think of it like, you know, let's say cruise mode or sport mode, right? There's not a specific kind of value or order to those things. So here's some, you can look at that, all these different kinds of samples. So what are these types of data? So like for CO2 levels, okay, that's quantitative. For number of siblings, quantitative, discrete, GPA, continuous, income bracket, ordinal, race, nominal, number of years of education, discrete, Yelp rating, ordinal. Okay. Now the next part we're going to talk about is file formats and data structure. So far what we've seen is CSVs, right? When we've opened up like the baby names, that was a CSV. But we're going to be looking at different kinds of data structures in this class. And as you do your work in your semester project, you might find more types than just these. So what are the key kinds of properties to consider when you're doing EDA? So the first one is the structure or shape of the data file, okay? The granularity is the next one. How coarse or how fine is the data? So something came up at work, and so they were asking me, we wanted to keep track of how many people were logging on to the website and then, let's say, submitting insurance claims. And I said, you want it at a category level, or do you want it at an individual, like person level, okay? Or individual unique person. So when by category, there's like students who sign in, there are company officials who sign in. So like your employer might be signing on to the insurance website to like administrate the insurance plan, versus you as a expat student doing study abroad might be signing in to submit insurance claims. So they want to know what kind of granularity this data. Well, I asked how granular of the data do you want to be able to analyze, okay? And so that's the kind of what's meant by this kind of granularity here. And then how the scope or how complete is the data, right? So here, I think if you think about scope, if you think about, like, for example, the rain and sewage measurements inside of a data set, if you were seeing it on a daily, let's say they're supposed to do the measurement every week, right? Then you're going to say, okay, it's every week that they're measuring and recording. But let's say that you're missing like a lot of segments of that data. So you know that your data is incomplete then, right? So temporality, right? The data situated in time. So this is another kind of example is when somebody records a time inside a record, we're sometimes just thinking California time, but there's how many other time zones in this world, right? There's a lot of different time zones. So you could be recorded in Eastern time zone. It could be recorded in, let's say, Bangalore time zone, which is just one big time zone for the whole country of India, by the way, which is quite amazing. But then you have, you can think about like South Korea or Russia or London, all the different time zones, right? So when they measure and record a timestamp, you really need to know what is the actual specific granularity or accuracy of that data. And then how well does this data sort of match reality, right? So that this one, I think, one that comes back to mind is, remember I told you at the early part of the weeks that when the COVID pandemic occurred, that they noticed, like, for example, that they thought there were no COVID infections happening on Sundays. It just that wasn't actually true. They just weren't recording it on Sundays. So it didn't actually match reality, right? Okay. Now we're seeing, okay, rectangular data. So we prefer the rectangular data for our analysis. And why do we like rectangular data? Because our Python libraries and our models likes to deal with rectangular data. So we try to get things into a rectangular format so that we can do our modeling and data analysis and cleanup in this way. Yeah, there's two different types of rectangular data table, which is what you've seen so far. The other one are called matrices. And this one we will see further when we actually get into our linear regression work. We won't get into it yet. So this one here, so how are these data files formatted? What, I cannot see that. Okay. So this one here is the case where we are dealing with unformatted data. In this case, when this one here is comma separated values, but as you can see, a lot of the values are broken across multiple lines. And so it's very hard to visually see it. So tab separated, and then CSVs, and then JSON. Okay. And so I think tabs separated values, comma separated value, you may have seen already those by dealing with like Excel and databases. And if you haven't seen JSON values, it's sort of the de facto data format nowadays for programming, right? So it's basically name and value pairs in a hierarchical way. And it's much more slimmer than XML of the old days. Which one is better? Well, which one do you guys prefer? Any particular type? JSON. JSON? Okay. Any other people vote another way? And why? My preference is actually JSON as well. Hopefully you guys seen that a lot of editors nowadays, let me just jump out of the slides here. And I was going to look at this editor here. So editor nowadays have a lot of ways to make the JSON data easier to read and then collapse. So here, I collapsed out the metadata and then just wanted to focus in on the data section. And then you can see that all the color coding that this particular editor does to make things a little bit easier to read. This one's very hard to read anyway, because there's just a lot of like this UDDI values inside of here. But as you can move things around, and the editor, as long as you don't break the format so much, then things will be easier to see like that, right? You can sort of like even bring things to the next line, and as long as you stick with that, you can sort of see that it tries its best to make it easier to read in this particular editor. Continue here. Oops. Okay. So unfortunately, we're in the real world, I think you might still come across a lot of systems that generate that gonna give you JSON data. They're gonna give you data in CSVs or TSVs. And it's, in such case, you should be able to know how to deal with it, okay? Or at least try to process it correctly. Because you're gonna see that in some of our sample data, there's a lot of new line characters, even in the CSVs. And the new line makes the data and the records kind of hard to understand. Here, so JSON's really common, widely used, very, very, very similar to the Python dictionary data structures. Okay. But the thing is, the problem with JSON is that it's not rectangular, right? So we need to be able to convert this JSON data or take out the pieces of data out of the JSON that we want to focus on and put it into a rectangular structure so that we can deal with it inside of data frames. Okay, so we need to take this kind of JSON structure, put it into some kind of a tabular, look at it in a tabular way, and then put it inside of a data frame. So then you can do all this type of data manipulation inside of pandas and data frames. I think hopefully most of you have seen XML before, and XML stands for Extensible Markup Language. It's still around, and there's a lot of data out there in the real world that's still in XML. And it kind of looks like this, a very, very verbose kind of data structure, because it has the beginning tags and closing tags, like the one that is highlighted and pointed out with the arrow. And then you're going to see often a lot of log files. Log files are, generally it's CSV format, but sometimes it can be just by spacing. It just writes things out and puts spaces in between. So here we're going to be able to now think about how we do these joins across various tables. So just like in, think about the SQL database classes you took. The primary keys in a database table is sort of like, in this case, for what we see on the screen, the order number would be the primary key. And it would basically be the main field that how that record gets stored, okay? And those primary keys have to be unique. And then the foreign key here, the foreign key is just a key that references like a dimensional table or another secondary table. So here, the order number references a customer ID, and that customer data or record exists in a separate table, and it just referenced here as a foreign key. Okay, so most of this, hopefully you guys will know from your database class, but again, a tabular structure, nested structure. So one is a tabular structure, the other is a nested data format. How are they generally organized? For like XML, they're not generally organized by records. So you have to then be able to convert or deal with these data into a record format. And does the data reference other data? Yes. And then when it references other data, then we're dealing with foreign keys into different tables. Right, and then next thing is about how they're encoded. So how are they, what is the data type actually in the record? Okay. Okay, so this is what we talked about, these primary keys and then foreign keys and these tables. They all sort of then tie into a common data mining concept. This is not a data mining class, but in data mining, they have a concept of fact tables and dimensional tables, okay? So fact tables, you could think of it like your order records. Your dimensional, that's a fact table. Your dimensional tables would be things like, you know, what day of the week is it? Or let's see, like another one might be like your service type of service calls. So when we talked about like the police records that we'll look over, you don't want to store the whole fact that it's a domestic violence issue, but you just want to store a reference to it through a foreign key, okay? And so that's the reason why you use that as a dimensional table, and you put the actual police report in your fact table. That's pretty much it on the, this is just a summary of what we talked about. Now we switch over to the Jupyter files. So this is an example of the JSON file that we're going to be able to digest and process through Python. Jupyter files. We looked at the lecture 5 already here. We're going to switch over to lecture 6 files. So in lecture 6, you open this up and look at it. Kind of the similar things that we saw before about opening up the CSV, sorting the data, doing the group by. Not that much different, but let me show you some other new kind of concepts here. So sometimes you want to be able to do your aggregation but you're not interested. You just maybe just want to pick the first record out of the group. So here you can see that we're grouping it by name, but see, by looking at name, there's 2 Alices. So if you were to group by Alice, I mean that by name, you'll get one group would have Alice, but would have 2 records. But here you're saying, I'm not interested in all the records, just give me the first record. So there, if you do that, you can then get to build a new result of just 1 record or the first record out of your batch. Okay. And so here, looking at the different kinds of attributes about your group by, looking at the number of columns, number of rows, being able to sort it, doing some kind of, here is you're doing a sum and then sorting it by year, okay? And then you can do some graphs with that as well to do your visualization of what the data looks like. Here you're doing math operations directly off of a filter call. So you're taking a group by and then running a filter access method on it. And when you call this filter call, you can actually specify a lambda function and do some sort of operation like this. You're saying on the count, do a mean, and then give me back only the ones that have a mean above 3.0. Many kinds of operations you can do here. Here's another example of a group by. Okay. Let me switch over to now the data cleaning one. So we're going to just talk about one section of this, and this one actually supposed to be across lecture 6 and lecture 7. We're only doing one part of this. So one part is we're going to be looking at. So here's some links I provided about being able to handle something called cufflinks and plotly, which are additional Python libraries for doing some graphing. So here's when we explore the data, we talked about this in the lecture slides, the different aspects about exploring the data. Here's the size. Here's the number of line rows. And then just keep in mind, number of lines does not mean that same number of records, okay? And then here, we are opening up a JSON file and just looking at the first 20 lines of the JSON file, not 20 records. So actually, this is called service calls, not just calls. So if you look at this JSON file, and then here is the service calls, which is a CSV. You're going to see that if you open this up, Some things you'll notice, and I pointed out before, that this is a CSV, but some of the data is broken across multiple lines. So here, you can sort of see an example here. Here's the comma, but then here's the continuation of this row, but then it continues across the next row. And then it terminates here with this comma here. So this one piece of attribute is across 3 lines, right? So that's how kind of messy this data is, that they've added new lines into a certain field. So what do we want to do with this CSV is that we want to be able to load it in, okay? And then load it in based on records. And the loading of the CSV is going to take into account the commas. But see now, if you see here, the particular one that spans multiple lines is right here. It says Berkeley, new line, the first part of the GPS coordinate, and then there might be another new line after that. Here's another one. It actually has a street address, Berkeley, and then it has a GPS coordinates here. So you can see that some records actually specify the street names. Other times it just says like a city. Sometimes it says street name and city and then GPS coordinates. So you can see that the data is not very consistent, right? So this is going to be, if you relied on being able to know what was entered for the street address, then you're going to know, okay, this is going to be some problems, because can you convert the GPS coordinates into street address? There is a way, but it's not going to be straightforward, not immediately straightforward. So some of the observations of data, the timestamp, 24-hour format of the time of the date timestamp. It doesn't specify the time zone. And then this thing called CVDOW, day of the week. And so it's encoding the day of the week as a number. So if you look back over here, this CVDOW is just a number, but that is actually a lookup into a dimensional table. Okay, so 4 maybe might mean like Thursday, 1 might mean like a Monday. I don't know offhand what it is. But here it is. Here's the dimension table. So here's an example of sort of taking this series here, or this column, day of the week, and then converting that into a more easier to understand version of that called day. So before we had this, we just generated a series by the order of what these values mean, and then did a merge with this value here and added then the corresponding value here. So that's one thing you can do with this merge between 2 data frames, not just combine them without any kind of logic, but with using the actual index as the way to look up into that dimensional table. The next one is about cleaning the block records. So if you were to just focus in on just this column here that I said, sometimes it contained street information, most of the time it contained the city and state, and then most of the time it contained the GPS coordinates. If we were to just try to harvest out just the GPS coordinates, this is a technique of using regular expressions to take out just the coordinates and put them into a separate two columns. And then once we take those two values out and put them into two separate columns, then we can actually put them back into the original data frame. So here is the data frame. So this is the original series with the coordinates in it, and then processing it to put the lat and lon into two additional new series or two additional new columns in this data frame. Then you can then process this a little bit better, okay? So you could either process it based on, you could calculate distances with the GPS coordinates, or you could take these data frames and you could actually plot it on a visual Earth map to see where they all are located nearby other kind of landmarks, okay? So if you were to actually try to plot these out, you see them, a lot of them are located like in downtown Berkeley, okay? And then this is just another way of just kind of looking for bad data. So looking for where the cases where we were not able to pull out the longitude or latitude, and just making sure that all the records did contain some of those data that you parsed out. Okay. The next part, okay, we'll talk about JSON data and then we'll stop here, okay, for the day. So taking that JSON data and then focusing in on just the tabular, we want to look at the JSON data and then look at just the tabular portion of that data and then be able to put that into a data frame, okay? So in order to understand how to do that, you actually have to visually look at the data here. So we can see that there is one couple of top data structures from the very top. There's meta that has all these different meta fields, okay? And we're not interested in the metadata, but instead we want to focus in on this top level key in the JSON called data. And inside this data, you can see that there's an array of records, okay? So that's what we want to be able to focus in on. So we load up the JSON here and then look at the keys. So from looking at the top level of that JSON, we know that there's at least two of those keys, the meta and then the data right here. Meta and the data. And then once we know, here you can look at all the keys within the metadata. And then here are, we're going to skip over the metadata portion. And then we're going to look at the data portion. Here, the data portion. So we're going to focus in on just the data portion and then iterate through the number of records that might exist. So you can actually compute how many records there are, and then just loop through them and then build them and put them into a database. Okay. So this is just a more a cleaner approach of taking that JSON file and then putting it into a data frame. All right. I think we'll stop here for now.